Welcome everyone to the first webinar of 2023. I'm Tony Roskilly. I'm Professor of Energy Systems at Durham University and a Director of Durham Energy Institute. This event is organized by the APSRC Network, H2 Network Hydrogen Fuel Transportation, and is part of an ongoing series of webinars looking at different aspects of hydrogen research in the transport sector. This webinar, we welcome two speakers that will present their findings on hydrogen-related research work. When we talk about hydrogen, that also includes hydrogen carriers as well. Our colleagues are from Brunel and Nottingham University, and I'll introduce them. Dr. Xinyan Wang is from Brunel University. He's going to present on advanced fuel propulsion technologies for low carbon transport. He is a UKRI Future Leaders Fellow on advanced fuels and propulsion technologies. He graduated with a master's and PhD from State Key Laboratory of Engines, Xinyan University in China. Then he moved to Brunel University in London as a RA, Centre for Advanced Powertrains and Fuels in 2015. His research interests include modeling and experimental studies of renewable and biofuels, advanced combustion processes, and novel hybrid powertrains for high efficiency and low zero emission transport. So over to you, Dr. Wang.
So first, thank you very much for inviting me. Actually, I have attended a few series webinars. I think I benefit a lot from these interesting talks. So I'm really glad today to have this opportunity to share our thought on future zero carbon transport. So the title of my presentation today is Hydrogen-Powered Zero-Emission Engines for Future Transport. Before my talk, I'd like to give a brief introduction of the Center for Advanced Powertrain and Fuels at Brunel. As one of the biggest engine research group and fuels in the UK, the center basically cover a wide range of interesting research topics around combustion engines and fuels. And in recent years, we have basically moved from fossil fuels to future fuels, including hydrogen, ammonia, alcohol, and e-fuels, and their applications in combustion engines. The center has a wide range of research facilities, including emission analyzers, gas analyzers for these novel fuels, and also combustion engines, including compression ignition and spark ignition engines facilities. And in order to facilitate the research and development of these advanced technologies, we have optical engines as well as laser diagnostics techniques in order to identify the combustion, injection, and the incident flows. And also we do a lot of modeling work, including 1D, 0D, 3D safety simulations. And in last 20 years, the center has published several important books on advanced engine technologies, combustion engine instrument, and the laser diagnostics. So today I'd like to cover three topics. The first one will be the challenges and the opportunities of moving towards net zero for the transport sector. So this graph shows the global temperature change in the last 200 years. Obviously, in last almost 50 or 40 years, we see significant increase of the global temperature. And this increase obviously is highly related to the carbon emissions. It is obviously, in the last 100 years, the CO2 emission or greenhouse gas emission has increased significantly. So in order to mitigate the global warming impact and also reduce CO2 emissions, the UK government has implemented very ambitious target. So by 2050, we are aiming to achieve net zero. And also the government set intermediate goal. For example, by 2030, we have to reduce carbon emissions by around 70%. And by 2035, the carbon reduction target would be around 80%. So these are very ambitious targets, but actually the decarbonizing is not straightforward. For transport sector, currently it accounts for around 27% of the carbon emissions. And obviously, we have alternative propulsion systems to decarbonize the transport sector, for example, electric vehicles. And we do see a significant increase for the light-duty vehicles or passenger vehicles. Here I show the cell data in 2021. And obviously for battery electric vehicle and hybrid system, there's a significant increase, almost 60%. And for mild hybrid, it also increased significantly, almost 55%. But if we look at the categories of these data, we will be able to find actually the increase of the pure battery electric vehicle only about 12%. So which means almost 88% of the vehicles still have the combustion engines burning fossil fuels. So it is even challenging for the heavy vehicles, for example, the heavy good vehicles, the aviation, light aircraft, marine sectors, and agriculture vehicles and other machinery vehicles. Because they are heavy, they would need a higher power density propulsion system, and they are more cost sensitive. So we have to consider the cost of the vehicle as well as the operating cost. So if I summarize the challenges into this graph, obviously for the fuel cell and battery electric vehicles, they will be gradually increasing their market share. But obviously we have to recognize currently they still have relatively lower market share. And obviously they have very limited applications. So for light duty vehicles or small cars, they are more suitable. But for some heavy good vehicles, it will be very difficult to be decarbonized with these new technologies. So this leads to a very blanket technological development for other heavy good vehicles. So we have to address the challenges here in order to achieve the net zero target by 2050. So the question would be, first, how can we develop the technology for these heavy vehicles? And secondly, is there any possibility we can increase the market share or the increasing rate of the market share for fuel cell or battery electric vehicles? So I think there are great opportunities here. First, if we look at the fuel used by fuel cell, obviously there are hydrogen-based fuels, no matter it's a pure hydrogen, ammonia, or methanol, or any other e-fuels. And secondly, the battery electric vehicles obviously use electric systems. And in the last 100 years, the engine technology has been significantly developed. So we do have a lot of advanced engine technologies which can be used for future low carbon or zero carbon propulsion system. So we do see a good combination here. If we can integrate the three elements, so basically the hydrogen, electric system, and optimize the engines, we'll be able to find good solutions for these transport sectors. And also with the increasing usage of hydrogen, increasing usage of electric system batteries will boost the development of the infrastructure for hydrogen as well as battery electric. So we'll be able to basically increase the usage of fuel cell technologies and battery electric system in order to achieve a real net zero society. So the second part will be the advantage of hydrogen combustion engines. As mentioned, always hydrogen is a zero carbon fuel or energy carrier. Currently, there are many produced from fossil fuel, but if we capture these CO2, we'll be able to produce the hydrogen without carbon emissions. But in long term, the target would be to use renewable energy to produce hydrogen, and they can be stored and distributed for the usage in industry as well as in the transport sector through combustion engines or fuel cells. Here at Brunel, we look more on the hydrogen combustion engines. There are several advantages. First, the carbon emission obviously will be zero, and the second point will be the engines can use low purity hydrogen. This can significantly reduce the hydrogen production cost. So, and also the combustion engine can make use of existing engine design and also hybrid electric architecture, and it will also significantly reduce the production cost of the propulsion system. And the cost will be very similar to existing diesel or natural gas engines. And also the hydrogen engine efficiency will be more or less the same as current gasoline engine. Once we develop a dedicated hydrogen engine, the efficiency will be around 50%. And in terms of performance, obviously it has good, excellent instant cold start and shutdown performance. So it is very feasible for powering vehicles. And in terms of the emission, obviously people are worried about the NOx emissions because it does have some NOx emissions. But by using advanced engine technologies, I will mention a little bit later, we'll be able to achieve near zero NOx emissions. In terms of durability, it will be quite similar to the existing natural gas engines, and also the development of hydrogen combustion engines will protect the existing engine infrastructure, fueling system, and also maintain the employment of engine engineer. And another important fact is total cost of ownership. So basically, it's not only the cost of the purchase cost of the propulsion system, but also the operating cost. So here's an assessment from AVL. So they compare the total cost of ownership between hydrogen combustion engine and the fuel cell. Obviously, from the data, we'll be able to see the total cost of ownership is significantly lower for hydrogen combustion engine, almost half compared to the fuel cell technologies. This means the hydrogen combustion engine can be a very cost-effective solution, which means we'll be able to have faster implementation. Then it can lead to much faster CO2 reduction. In the third part, I will slightly discuss a few combustion engine technologies suitable for hydrogen engines. So once we want to develop a hydrogen combustion engine, we have to recognize the difference of the fuel properties. Hydrogen is a unique fuel. First, the laminar flame speed is quite high compared to the other fuels. And secondly, the hydrogen has much wider flammable range, as shown from this graph. The hydrogen can burn from 5% to 75% mixture. And thirdly, the hydrogen ignition energy is minimal compared to other fuel, which means hydrogen can be easily ignited. So we have to recognize the unique properties of the hydrogen when we develop hydrogen combustion engines. So the first point I want to discuss is a fuel supply method. So obviously we can make use of existing spark ignition engine or gasoline engine and the compression ignition diesel engine to burn the hydrogen in engines. So the easiest way to do this is to retrofit the engine to have a port fuel injection system. But obviously, it can be achieved with minimum cost, but there are a few downsides because of the unique property of hydrogen. So first, it will displace a lot of space if we inject the hydrogen into the intake port. Then we'll reduce engine power output. And secondly, because of the lower ignition energy, we may get some backfire in the intake system, and we don't want to have that risk. And the second technology would be direct injection. Obviously, we don't use port fuel injector, but we modify the cylinder head to have a dedicated direct injector. In that sense, we don't inject the fuel into the intake, but we inject all the fuel into the combustion chamber, so we can avoid any backfire. And also we can maximize the usage of the intake airflow to improve engine power performance. But as mentioned, we need to develop dedicated cylinder head, which will increase the cost of the engine. And the second aspect I want to discuss is combustion mixture preparation. Obviously, we can keep running the engine with the stoichiometric condition. This has several advantages. First, we'll be able to have much better power performance and the transient engine operation. And also we can make use of exhaust gas after-treatment system. For example, in gasoline, it's a three-way catalyst, but it do produce a lot of NOx emissions. So alternatively, we can run the engine at a very lean condition, and there obviously we can increase the engine efficiency. Secondly, we'll be able to reduce combustion temperature. This will reduce NOx emissions a lot. And the right graph shows the data from Bosch. And obviously here, with when we run the engine at a low load condition and the medium load condition, actually the NOx emission is almost zero compared to the lambda case, as shown with the green line. So when we increase the load, obviously the NOx emission increase, but it's still quite low. And also the efficiency has significantly improved when we run lean condition. And the last point I want to mention is integration with hybrid system. Obviously, we can, when we use a hydrogen engine plus hybrid, first we'll be able to have a higher energy density of hydrogen, which means we can have a longer mileage, and it can eliminate or reduce external charging, which can increase the flexibility, which is quite important for heavy good vehicles. And third, load leveler. Basically, we don't run hydrogen engine at full engine speed and full load condition. We can use electric system to assist low speed, low load, and high load conditions. Then we only run the engine at certain load conditions to further improve the engine efficiency. And also by using electric machine, overall the efficiency will be better, the torque power performance can be better. And for some vehicle, they can use regeneration ability to, for example, to recover the energy from braking, and also the start-stop function to further improve the system efficiency and reduce fuel consumptions. So in the last 4 or 5 years, Brunel has developed our own fuel flexible engine, which can run hydrogen fuel as well. It is a dedicated two-stroke engine, which has a very high power density. So it can be easily converted to a dedicated electric generator, which can be easily scaled up for different applications. And in that sense, basically, it is just a dedicated generator for electric vehicles. So I think I will summarize my talk. So hydrogen combustion engines can make use of existing engine technologies and have less requirement on hydrogen purity, therefore becoming an important solution for carbon reduction in transport sector. And the direct usage of hydrogen in existing combustion engines via retrofitting is possible in short term, while further research and development of dedicated hydrogen engines with ultra high efficiency and zero emission is vital for its wide applications in long term. The integrated hybrid electric hydrogen engine can be a promising zero emission propulsion solution for a range of transport application, and the deployment of hydrogen engines would also boost the deployment of hydrogen fuel cell and battery electric systems in long term. So with the strong support, we received over £3 million from UKRI industry as well as Brunel University. We have built up a dedicated hydrogen research lab for the R&D of hydrogen combustion engine technologies by using novel thermodynamic engine testing, optical laser diagnostics, and advanced numerical modeling. And that's all. Thank you very much.
Okay, thank you very much, Dr. Wang. Very interesting presentation.